Hi guys, tonight's lesson is on inequalities. Hopefully you're going to be taking your notes along the way so that you have something to refer back to when you're doing your work. So you've been working a lot with equations, so I'll spend a little time talking to you about the difference between the two, giving you some background knowledge, and then we'll get to the bulk of the lesson. So you've been working a lot with equations, and just to review, an equation is a statement that two expressions are equal. So for example, 2x plus 3 could be equal to 4x. So you know how to solve that for x and figure out the value of x. And so x in that case is just one value. An inequality is a little bit different. We could write those same expressions, 2x plus 3, but with an inequality you wouldn't have an equal sign, you would have an inequality symbol. So in this case I'll say greater than 4x. So you solve these the exact same way by isolating the variable. It's just your solution means something different. So in an equation, when you solve, you get one value of x, and in an inequality you're getting a set of values. So I'll explain that a little more as I do some of them with you, but when you get your result, x doesn't equal one value, but it equals an entire set. So something greater than x, a set of numbers greater than x, or a set of numbers less than x, or sometimes greater than or equal to x, or less than or equal to x. So an inequality is a statement that two expressions are not equal. So anything you get on the left in this case has to be greater than what you get on the right. So you can see how an entire set of values could make the left greater than the right. So I'll continue through some examples. First I have to give you some background knowledge before we can move on, but by the end of the video this should all make a lot more sense to you. Okay, so first you have to understand the symbols in an inequality, and this should be reviewed to you from prior math classes, but there's the greater than symbol and the less than symbol, and then there's also greater than or equal to and less than or equal to. So when you solve inequalities, oftentimes you don't just solve them, but then you graph them visually on a number line. So in order to graph them, you'll need to know what the graph of these look like. So greater than, you graph these on a number line. So let me draw a number line here just to give you a visual with 0. And you should recall that the numbers to the right of 0 on the number line are positives, and the numbers to the left of 0 on a number line are negatives. And so the further right you go on a number line, the larger your numbers get, and the further left you go on a number line, the smaller your numbers get. So when you're graphing greater than, your arrow would always go right on a number line to show numbers greater than x. And when you're graphing less than, you would make your arrow go left on a number line to show numbers less than x. Now there's something else you need to know. Whenever you're graphing greater than or less than, you use an open circle at the start of your arrow. Whenever you're graphing greater than or equal to or less than or equal to, you use a closed circle at the start of your arrow. So I will do some examples of this as we go along, this is background information that you'll need to know to be successful in the lesson. So you'll see on your note page I asked you to fill in some information about this. So you might want to pause the video now to make sure you get that in there. So on your note sheet, when graphing an inequality on a number line, we use an open circle for blank and blank, but we use a closed circle for blank and blank. So you might want to go fill in those symbols now. So we use an open circle for greater than and less than, but we use a closed circle for greater than or equal to and less than or equal to. So here's the first example on your notes. I'd like you to do this with me. It's to draw the graph of x is greater than 2. So using what I talked to you about on the last page, we need a number line and we have to find 2 on the number line. So oftentimes you'll be given a number line, but sometimes you'll need to draw it. So here's 0 on the number line, and so to the left of 0 we would have our negatives. So I'll just draw in a few of those negative numbers. To the right of 0 we'd have our positives, so I'll draw in a few of those. And so we need x is greater than 2. So we go to 2 on the number line, and this is just a greater than, so I need to put an open circle at 2, and x is greater than 2, so I draw an arrow to the right in the greater than direction. So this is my graph of x is greater than 2. It's a visual way of showing that all numbers greater than 2 would make this inequality true. So oftentimes students ask me at this point, where do I put the arrow? Where do I stop and start the arrow? It doesn't matter. You can make the arrow part as long or short as you want, because the arrow is simply saying this line continues forever in this direction, showing all numbers greater than 2. Let's do a couple more here. Example 2 on your note page is x is less than 2. So again, I need to find 2 on my number line. And so it's less than 2, so I'm going to use an open circle. The numbers less than 2 are to the left, and so I draw an arrow going left, showing the numbers less than 2. Again, you should be drawing and copying this on your note sheet. You may pause the video at any time to do so. X is greater than or equal to 2. I go to 2 on my number line. This is a greater than or equal to, so I need to color in my dot, color in my circle. I always like to remind students a nice easy way to remember that is 2 would be included in the solution of x is greater than or equal to 2. Since 2 is greater than or equal to 2, I color in the circle to trap 2 in my solution. If x is just greater than 2, 2 is not included in the solution, so I leave it open to let 2 escape. So x is greater than or equal to 2. I'm actually going to change my color here so it stands out. So x is greater than or equal to 2, so I color in my circle, and I need all the numbers greater than, so my arrow goes to the right. And the next inequality is x is less than or equal to 2. So again, I find 2 on my number line. I'm looking for all the solutions that are less than or equal to 2. So I color it in because 2 is included in the solution. I want to trap it in there. And I go left to show all the numbers less than 2 are also included as solutions to this inequality. So all numbers to the left of 2 on a number line would make this inequality true. So here's where the lesson really comes in. These are the things you'll be doing in your homework or in class tomorrow, actually. So we're going to solve some inequalities. So this is where you'll really gain some understanding here. So we're going to subtract. We need to solve for x here. We need to find out what values of x would make this inequality true. So we have to solve first. So we're going to subtract 4 from both sides of the inequality. And we get 2x is less than 7. Wow, I was really hoping this one would work out evenly. I didn't write the best example here, now did I? So 2x is less than 7. And I divide both sides by 2. And x is less than 7 divided by 2 is 3.5. So it wasn't too bad. Okay, so x is less than 3.5. So all numbers less than 3.5 would work to make this inequality true. So as long as I choose a number less than 3.5, if I substitute it back into the inequality, I will get a solution where the left side of my inequality, or what I get out on the left, is less than 11. So let's pick something nice and easy. Let's choose 3 because 3 is less than 3.5. So let's try it out. Let's substitute a 3 in here. 2 times 3 is 6, and 6 plus 4 is 10. And yes, it's true, 10 is less than 11, so that works. Let's do another nice easy one, 0, because 0 is less than 3.5. So let's say we substitute a 0 in here. 2 times 0 is 0, and 0 plus 4 is 4, and 4 is less than 11. So as you can see, as long as you pick a number less than 3.5, this will create a true inequality. So the solution to this inequality is all numbers less than 3.5. So we need to find 3.5 on the number line. So I'll go with 1, 2, 3, 4. 1, 2, 3, 4. 3.5 would be, about halfway in between there. And so this is a less than, so it's an open circle, and we need all numbers less than 3.5. So everything along that arrow is a solution to this inequality. So again, I wanted you to copy this example in your notes. So pause the video if need be. And one last example here is to solve 3x minus 2 is greater than or equal to 7. So again, solve this just like you would an equation. I'm going to add 2 to both sides. I get 3x is greater than or equal to 9. I will divide both sides by 3, and I can see that x is greater than or equal to 3. So any number greater than or equal to 3 will make this inequality true. So I will graph that on the number line, 1, 2, 3. It is a greater than or equal to, so I'll need a closed circle. Greater than or equal to 3, I head to the right, because that's all numbers greater than or equal to 3. So of course I always like to test it out before I move on, and I will pick any number greater than or equal to 3. Well, 3 is greater than or equal to 3, so I could substitute in a 3. So 3 times 3 minus 2 should be greater than or equal to 7. 3 times 3 is 9, minus 2 needs to be greater than or equal to 7. 7 is greater than or equal to 7. That works. I like to usually try 2 just to make sure. So I'll pick some other number greater than or equal to 3. I'll try 5. So 3 times 5 minus 2 should be greater than or equal to 7. 3 times 5 is 15, minus 2 needs to be greater than or equal to 7. 15 minus 2 is 13, and that is greater than or equal to 7. It checks out. So the solution is x is greater than or equal to 3. I show my solution on a number line by closing in the circle because I have an equal to, and so 3 would be included in this solution, and I go greater than or equal to. So hopefully you have a greater understanding of inequalities, the difference between an equation and an inequality. Equations are a statement that two expressions are equal, and you will only get one correct solution. X is one value, equal to one value. In an inequality, it's a statement that two expressions are not equal, and when you solve it, you are looking for an entire set of numbers that make the inequality true. So hopefully you are prepared for class tomorrow. We will work on these in class. Hope you have a great night. I will see you soon.